Today we're going to start talking about how I would simplify radicals and a couple of different characteristics. A lot of this is a review for you. However, there are some key definitions that we need to make sure that we go over. So I'm going to go ahead and highlight my title because this is going to go in my notes section. And I'm going to go and I'm going to highlight all the borders of my boxes. And if you want to do that ahead of time, you can. There's a total of 3 boxes, or you can highlight them as we go. I'm probably going to highlight them as we go, just for purposes of some time here. So the first thing I need to talk about is these properties of radicals, and this is what's new for what you haven't talked about. We haven't discussed this yet. So it says the nth root, let me write that better, the nth root of a number raised to the nth power is equal to the absolute value of a if n is a positive, even integer. So if n is even, which means I have an even root and an even degree, the outcome is the absolute value of whatever it was simplified. And I spelled integer wrong. I just noticed that. So now I have the nth root of a to the nth power is equal to just a if n is a positive odd integer. So if n is odd and n is also odd, so odd, odd, then it's just a. If n is even, then my outcome is the absolute value of a. So how I remember this is I have this phrase, because you're going to have to now include this absolute value along certain answers, is I want you to think even, odd. So even means I have an even root. The second even means I have an even degree under the root. And the odd means I have an odd degree out of root. So if I have an even root and an even degree under my root, but then the outcome when it's out of the root is odd, it's going to get an absolute value sign. So let's go ahead and let's look at this. So if I look at this first one, I'm going to go ahead and simplify. So square root of 12 can be simplified to 4 and 3. So 4 is the biggest perfect square. So now I have 2 on the outside and 3 on the inside. X squared can be simplified to x, because x times x, 1x comes on the outside. You used to be done here. However, now I have to think about my even, odd rule. So if I look at the original degree of this problem is even. So okay, so my root is even. So now I'm going to look at the exponent, the degree. That has a degree that's also even, so even. Now look at my outcome. My outcome has a degree of 1, which is odd. So since it's even, odd, x gets an absolute value sign, and I'm done. Let's go ahead and let's look at this number 2. If I just preview that even, odd rule, look at my root. My root is even, so that's the first even. Now look at my degrees. X's degree, is it even? Nope. How about y's degree? Is y's degree even? Nope. So I'm not going to have any absolute values in this problem. So square root of 24 is 4 and 6. Square root. I get 2 on the outside and 6 on the inside. X to the 9th. That's x to the 8th and x. So since this is even, I can divide by 2 and get x to the 4th. And x left over. Y third is y squared and y. So y squared divided that by 2 is just y. and I have a y left on the inside. And because I already previewed even, even, odd, I instantly know none of it's going to work, which is why I don't have any absolute value signs. So let's go ahead and let's look at number 3. Number 3 is a cube root. So I need to find out all the numbers that go into 54. So 2 and 27, and then I have 9 and 3, and then I have 3 and 3. So with a cube root, I have to have a group of 3. So 3's break out. 2 is stuck inside. So x to the 7th has to be in multiples of 3. So x to the 6th and x. So that's going to be x squared because I'm dividing it by 3 because it's a cube root. Y to the 11th is y to the 9th and y squared. Y to the 9th, divide that by 3 is y cubed. And then I have y squared left over. So notice I'm not having to do absolute value signs because my root is not even. My original root is odd. If I come over here and I look at number 5. Number 5, again, it's a 5th root. And I'm not looking at number 5, it's number 4. So factors of 32, it's 2 and 16, and 8 and 2, and 4 and 2, and 2 and 2. So I have to have a group of 5. 1, 2, 3, 4, 5. So a 2 escapes. So now a to the 6th makes a to the 5th and a. So divide a to the 5th by 5. I get a. And a is left on the inside. B to the 10th, that's a multiple of 5. Divide by 5, that's 2. C to the 14th, that's c to the 10th and c to the 4th. C to the 10th makes c squared. Gotta put my 5 in my root power. And c to the 4th is left on the inside. Do I have to do this even, even, odd trick with the absolute values? No, because 5 is an odd root. So I want you to go ahead and I want you to try 5 through 8 on your own. Remember, if it's an even root, you have to try and you have to look for the even, even, odd values. When you finish, you can go ahead and unpause this video and the answers will be on the screen. So the answers are on the screen. So if you have any questions on any of those problems, you can come and ask me. If not, we're going to go ahead and we're going to keep going. So I have product and quotient properties that I need to know. And we've already done these again, but we're just going to really quickly review them. So product quotient tells me if I have an nth root of a times b, that's the same thing as saying the nth root of a times the nth root of b. That's the product rule. The quotient rule is if I have the nth root of a over b, that's the same thing as saying the nth root of a divided by the nth root of b. So if I look at number 9, I'm going to go ahead and I'm going to put everything under one big cube root. And I have 27 and 5, and then I have a and a to the 4th makes a to the 5th, and I have b cubed and b, which makes b to the 4th. Notice I didn't multiply 27 and 5 because I'm going to have to break them down anyhow. So I know 5 is prime, so now I'm left with 9 and 3, and 3 and 3. So I have 3 3's that are going to escape. 5 is going to stay inside the cube root. A to the 5th is a cubed and a squared. So that's a with an a squared on the inside. B to the 4th is b cubed and b. So that's b and b. And I'm done. If I go ahead and I look at number 10, number 10, well, I have 8 over 4, which can simplify to 2. And then I have 50, and then I'm looking at that, my radicals, I can clean that stuff up as well. So the square, 54 divided by 3 is 18. X to the 5th and x cubed is x squared. So now I can go ahead and clean this up. This is 9 and 2, square root, square root. So I have 3 rad 2, but I got to multiply that 3 by 2. So I have 6 rad 2. X squared can clean up to x. So now, because this is a square root, I got to check the even, even, odd. So this is even. This degree is even. Notice the outcome is odd. So it's going to get the absolute value sign. If we go ahead and we try Actually, I lied. I want you to try number 11 and number 12. Number 12, I want you to try. Number 13, we're going to put a circle on it. We're not going to mess with number 13 until next class. But I want to talk about number 14. Number 14, I can clean up this a little bit and make one big radical. And I could say 5x squared on the top and 2y squared on the bottom, right? So now if I go ahead and I clean this up, 5x squared over 2y squared. How do I get that radical out of the denominator? Well, I have to rationalize it. So I got to multiply by, sorry, it's not treating me well here. I got to multiply by 2y squared over 2y squared. So if I multiply these together, I get 10x squared y squared over 2y squared, because whenever you multiply two radicals together, you just get the insides. So now I'm going to go ahead and clean this up. 10, square root of 10 I can't clean up, so 10 stays inside. X squared and y squared changes to x and y. And now I have 2y squared on the bottom. So now I can keep cleaning stuff up. So my y's can cancel out. And so I have x squared root of 10 over 2y. But notice, I got to go back and I got to make sure the even, odd trick doesn't work. So, or it does work. So if I look at my radical that I started with, it's even. X is even. It came out odd. So x needs an absolute value sign. And I'm done. So I'm going to go ahead, you try 11 and 12. I'm going to go ahead and put the answers up on the board, and then you can check your answers when you're finished. So the answers are on the board right now, so you can go ahead and flip your paper whenever you're ready to go. So now I want to talk about the sum and difference of radical expressions. So what this tells me is if I have a to the x root of a number plus or minus b to the x root of some number, that's going to equal a plus or minus b x root to some number n. So the big thing with these is I always want to simplify radical before you CLT. Always simplify the radical before. And this is just like combining like terms. You can only add the terms that are the same. Radicals can only be combined with radicals that are the same. So if I look at this problem here, they both have rad 5x, so I can go ahead and add up their coefficients. 3 and negative 2 make 1, so I'm left with 1 rad 5x, which is just the square root of 5x. If I go ahead and I look at number 2, notice this one has a square root of 7 and this term has a square root of 5. Can I simplify the square root of 7 to make the square root of 5? No. Can I simplify the square root of 5 to make the square root of 7? No. So my answer is exactly what it is. It's already in simplified form. There's nothing else I can do. If I go ahead and I look at number 3, notice number 3, none of these have the exact same radical. So I got to simplify first. So I'm going to simplify 12, that's 4 and 3, which makes 2 rad 3. 75 is 25 and 3, which is 5 rad 3. And then I have minus rad 3. So now I'm just going to combine all my coefficients because all my radicals are the same. 2 and 5 make 7. 7 and negative 1 makes 6, so I have 6 rad 3. So you're going to go ahead and try number 4 on your own. But I'm going to move to number 5 real quick so we can talk about it. Number 5, I'm subtracting these two, so I'm going to distribute that negative first. Now I'm going to simplify. 18 goes into 9 and 2, so that's 3 rad 2. And 50 is 25 and 2, so that's 5 rad 2. So now I'm going to combine like terms. Negative 5 and negative 6 make negative 11. 3 rad 2 and negative 5 rad 2 make negative 2 times the square root of 5. So that leaves you 6 and 7 to be able to do. So let's now try 8. 8. I got to double distribute. So I get negative 12 times negative 6 rad 2 plus 20 rad 2. And now I have plus 10 times rad 2 times rad 2, which is just times 2. So this is negative 12. And then I can combine these and make plus 14 rad 2. Plus 10 times 2 is 20. So now that's just 8 plus 14 rad 2. So I want you to go ahead and try all of the problems that we did not do. So that is 4, 6, 7, and 9. And then unpause this video and I will have the answers on the board. So go ahead and check these problems out. If you have any questions on the ones that you did, make sure you come and you ask me. Last part, rationalize the denominator. How do I rationalize the denominator? Well, you have to multiply by the conjugate. If it is only a one-term problem, you just multiply by the radical. So it's illegal to have a radical in the denominator, so I'm going to multiply by the conjugate. So here I'm just going to multiply by rad 3 over rad 3. So I have 1 rad 3 over 3, which is just simplified to rad 3 over 3, and I'm done. If I look at number 2, I have to multiply by the conjugate. Well, what's the conjugate? 1 minus rad 3. So on the top, I'm going to distribute. I have 2 minus 2 rad 3. On the bottom, I have to double distribute. So I have 1 minus rad 3 plus rad 3. And then rad 3 times rad 3 is 3. So those cancel out. I'm left with 2 minus 2 rad 3 over negative 2. So now I can clean everything up. Negative 1 plus 1 rad 3, which is just negative 1 plus rad 3. So I want you to go ahead and pause this video and try 3, 4, and 5 on your own, and then you can unpause this video to check your answers. So all of the answers are listed now. If you have any questions, make sure you go ahead and you ask me, or you ask, one of your peers so that you understand what's going on.